Good evening. Welcome back to the chemical bonding and the molecular orbital theory. Interesting theory and the latest theory for this thing is quantum mechanics theory actually. So this is very interesting and but slightly confusing. Right? We will see. This will solve the most of the problems of our these things and all. Why this has started is because of the valency bond theory is explaining about all the shapes and hybridization is giving all everything, but it is not able to explain the paramagnetism and diamagnetism of the molecules. So that was the only shot back by the valency bond theory. So this theory is started by the latest quantum mechanics by Mulliken and Hund. See here, the difference slightly you please understand, try to understand. In the molecular atomic hybridization, same within the atom, the sp or spd or sp2 or sp3 like this within the atom the hybridization is taking place and equal number of hybrid orbitals are happening. But in the molecular orbital theory, slightly different. That is intra. This is intra means whatever is going to be form bonding means hydrogen and hydrogen. Hydrogen and hydrogen, if you see these two s orbitals are making these atomic orbitals are combining and forming a molecular orbitals double the this one, double the atomic orbitals. One is bonding and another is called anti-bonding molecular orbitals will form. So we'll see this some silent features. So similar the electron molecule present various molecular orbitals also electrons are present in like in the atoms only. Here also the first thing is same energy levels. Same energy levels of the levels of atomic orbitals only will combine atomic orbitals. Combine and gives the molecular orbitals. And here one more is in addition to they are also the same thing but same energy levels and all. Here the same symmetry also is required. Same symmetry. Same symmetry is required. Same energy levels forming, and here the formation is bonding molecular bonding orbital, bonding molecular orbital and anti-bonding double. Actually suppose two atomic orbitals are coming, two bonding molecular orbitals will form and the two number means one bonding orbital and the one anti-bonding. Then 4. Suppose 2 is atomic orbitals, one bonding will form and one anti-bonding will form. Double. Next, the atomic orbitals energy is more compared to the bonding orbital. Bonding orbital is more anti-bonding orbital. Means anti-bonding orbital energy levels are high. Atomic orbitals energy levels are more. That means this is atomic orbitals energy levels are more. This is less. So sorry. Bonding orbitals is atomic orbitals is more than the bonding orbitals. Bonding orbitals energy is much more less. Finally, bonding orbitals is less energy compared to the atomic orbitals, and this is much more. So bonding is less, atomic, less anti-bonding. This is correct. This thing. Bonding is much less compared to atomic. That means this is the least energy, so this will form first. Fine. See here also the same Aufbau principle and all the other principles will form, and then actually this will be represented by psi. Psi function is a Schrodinger equation function and all these things. Calculations are very difficult and very high levels of the MSc and other molecular theory. So for the lower level classes and all, linear combination of atomic orbitals is introduced. So that is very easy. So mathematical equation is when two atomic orbitals A and B are combining, when two molecular orbitals are psi molecular orbit are equal to, this is psi, one is the atomic orbital plus or minus another psi molecular B. If it is hydrogen atom only, both are same, but the two differentiate 1 and 2 we want. So that means bonding orbitals is normally represented by sigma, that is psi A plus psi B. Similarly, anti-bonding is represented as sigma star is equal to psi A minus psi B. Anti-bonding. So, a pictorial representation is, suppose this is the energy level of psi A. So that means atomic orbital of the one. This will be split into this two. Here, this is the hydrogen atom I am writing. This is sigma equal to psi A plus psi B, and then this is psi B. This is split. So this is a sigma star. Sigma star equal to psi A minus psi B. This is anti-bonding. This is a bonding. This bonding energy is lower. This is what I have. The bonding sigma, these energy levels are compared to the atomic orbitals of psi A and psi B. It is lesser, lower. So it is the increasing level of the energy. Energy is increasing like this. So anti-bonding levels is more. In the normally, so anti-bonding sigma star will not have any electrons. Electrons are filled in the bonding only. That is the molecular orbital theory. So the conditions are same, the same symmetry and same this thing. Normally z-axis will be the participating and all. And one more condition also normally here, with the overlapping should be more. Lapping should be more. That is also another condition for the formation of the things, or the conditions for a combination of atomic orbitals and all these things. So suppose what are the types of the molecules? Types are normally it will be represented as sigma, pi, delta, like this. These are the normally this thing. Sigma is more symmetrical around the bond axis. Symmetrical around bond axis. Bond around bond axis. This is not symmetrical. Pi is not symmetrical, and even delta is also not. So there will be so many 1s bond sigma moleculars, and the molecular orbital, the 2px, 2py, 2px and 2py, and 2pz, 2px, like this they are always on. And the if you see the energy levels and all these things, energy levels is the molecular orbitals energy levels. Sigma 1s, then sigma star 1s, then sigma 2s, sigma star 2s, sigma 2px, like this it will go on. Sigma 1s is lesser than sigma star 1s, is lesser than sigma 2s, lesser than sigma star 2s, lesser than sigma 2px or 2p x, y, z and all. Almost all the three are same. Then pi star, it will be like this. Okay. Now, which is the stable? This is the most important parameter, is stability of the molecule. stability of the molecule. Please remember, this is the one has to be more. Suppose bonding in the bonding orbital, Nb is the number of electrons occupying in the bonding orbital. Number of electrons occupying in bonding, that is here, is Nb. If you see Na is number of electrons occupying in the anti-bonding. Nb should be, Nb is greater than Na, Nb greater than, bonding should be more than Na, it is stable. If Nb is less than Na or Nb equal to Na, it is unstable. Molecule, whether it is forming or not, suppose helium-2, will it form or not, all these things will be from this. Nb, if it is more than Na, it is stable, means diatomic or triatomic or whatever it is. If Nb is lesser than Na or Nb equal to Na, it is unstable. So we will see then bond order. Bond order is also very important for this thing and all. We will see tomorrow. Okay, thank you.